Hi, dear students. Hope you are all doing good. Okay. Uh, so, so we are continuing our important sessions on NEET 2024 revision series. Okay. I hope all of you have written your JE exams well. So I hope you have seen JE 2004 question paper. It's completely from NCERT, line by line NCERT. Okay. And also the question paper was too simple actually. Okay, so we can't expect more for NEET exam also. It will be completely from NCERT, and soon we will be taking another session, something like what we say. We are completely dealing with each paragraph of NCERT. So soon that session will be started. Okay, so today we will continue with our another three important questions for Brainiacs capsule. Again, these three questions are based on the concept nucleophilic addition reaction. Okay, yeah, let's get started. So the question here is treatment. Okay, the question, I hope all of you could see the screen well. So the question here is you could see, yeah, let me take a nice color. Yeah, treatment of cyclopentanone is this one with methyl lithium. How many of you heard about this particular reagent, methyl lithium? Gives which of the following species? Okay, this question is very important. Why means here we know a reagent called Grignard reagent, RMGX. This is one reagent where we are seeing a carbon being connected to a metal. Okay, so this is another reagent. Methyl lithium is another reagent where you can see carbon getting connected to an S block element lithium. Okay, so what is the fundamental difference between a methyl lithium and a Grignard reagent? So that is what the examiner is checking with you with this particular question. Okay, so let's try to start doing this question. So we know that this is our cyclopentanone. Okay, and I am going to treat with methyl lithium. So please understand again, methyl lithium means I know that lithium is an electropositive element. What it will try to do while breaking the bond, it will push its electron to an electronegative element like carbon. So it will undergo heterolytic fission like this, and the carbon will acquire negative charge. The similar thing will happen if you are taking a Grignard reagent, CH3MgBr. So bond will break in such a way that magnesium is an electropositive element, so it will push its electron to the carbon, and again you will get CH3 minus. But the difference here is, here the role of this CH3 minus is to behave like a base. Now the most important question here is, sir, in Grignard reagent's case, the CH3 minus that is generated there will behave like a nucleophile, sir. So what is the difference between a base and a nucleophile? The fundamental thing you need to remember here is a nucleophile is defined as, or I can say by looking at a negatively charged species, I cannot say whether it is a base or a nucleophile. I can say that negatively charged species as a nucleophile if it go and attack the vacant orbitals of carbon. If carbon has a vacant orbital like this, you can see a deficiency, then I can say that particular negatively charged species will behave like a nucleophile. But sometimes the negatively charged species have a tendency to attract H plus. I know that an acid is something which donate H plus, and base is defined as something which will attract H plus. It is not donating, it will attract H plus. So I can say in methyl lithium, when it undergo heterolytic bond fission, the methyl carbanion produced there will behave like a base and attract or abstract H plus. Now the question here is, sir, in cyclopentanone, we can see, sir, here two hydrogens are available. Sir, here also two hydrogens are available. Here also two hydrogens are available, and here also two hydrogens are available. Sir, from where it will abstract H plus? That is also very important question. So please remember, whenever there is a carbonyl group is present, the nearby carbon is called my alpha carbon. And this carbon, if it has how many hydrogen, all those hydrogens are acidic in nature. Why? What is the reason? Very simple, sir. How will you check whether a hydrogen atom is acidic or not? Very simple. Remove that hydrogen as an H plus. Remove that hydrogen as an H plus. So what you will get? CH2 minus. Now check the remaining structure. What you are obtained after removing the H plus is stable or not. Why? If the remaining structure is stable, that means that particular species or this particular species can remove that hydrogen as H plus. If somebody is capable of donating the H plus and the remaining structure is stable, then I can say that guy will behave like an acid. Very simple. So simple, I have removed this hydrogen as an H plus here and I got the remaining structure. Then I understood that negative charge, single bond, double bond. So this is stabilized by resonance. This will move towards here. Then this pi bond will polarize like this. So I can say the remaining structures are stabilized by resonance. Or I used to tell to my students, whenever there is a carbonyl group, if there is nearby carbon present and if that many hydrogens are present in these carbons, though all those hydrogens are acidic in nature. In Malayalam we will say, this is our putuviti. So putuvitiയുടെ അടുത്തുള്ള കാർബണിലുള്ള ഹൈഡ്രജൻ എല്ലാം acidic. This is very simple to remember. Okay, so here also the same concept. I can say this is cyclopentanone. There are 2 hydrogens here present. There are another 2 hydrogens present here. All 4 hydrogens are highly acidic in nature. So what will happen? They have a tendency to move out as H plus. And here already you are using methyl lithium. Okay, here already you are using methyl carbanion. This is ready to absorb the H plus. Automatically the H will move out as H plus and you will get a structure that is like this, something like this. From here the hydrogen is moving out as H plus. So this structure is called cyclopentanoyl anion. Why it is called anion? Because of the negative charge. Pentanoyl means it has 5 carbon atoms, so it is called cyclopentanoyl anion. Clear? It's a very important question. So my answer for this particular question here is cyclopentanoyl anion. Option 4 would be my correct answer. I hope the answer is clear for you. Any doubt? Okay. So this question I am expecting, it's a very important question. So importance of methyl lithium, I hope you understood. Any doubt, feel free. Please put this, if you have any doubt, put it as a comment in our comment box. I am ready to answer you. Okay, so let's move to the next important question. Okay, this is also very important, again based on pure NCERT. Okay, the question here is, all of you please go through the question. The question here is, I can say, acetone, okay, is treated with the excess of alcohol, that is ethanol is used here, in the presence of hydrochloric acid. The product obtained is, it's a direct reaction given in the NCERT. So how we need to do this question? That's very important. So this is my acetone. Okay, you can see that this is acetone and I am using ethanol. Please understand, here we are using excess of ethanol. That means there are more amount of ethanol is present in the medium, and this happens in an acidic medium like HCl. Okay, now what is happening? So I can say the ethanol, this will undergo heterolytic fission in such a way that oxygen being more electronegative, the electron will go to oxygen. It will create a species, a nucleophile like this, CH3 ethoxide ion and NH plus. And what will happen? We know that all aldehydes and ketones, since there is electronegativity difference between carbon and oxygen, it will undergo polarization to produce positive charge here and a negative charge here. Why? Because the pi bond will have a tendency to move towards oxygen because of the electronegativity difference between carbon and oxygen, and that is greater than 0.5. Okay, now what will happen? The nucleophile will first attack the positive charge of the carbon. It's a common mechanism in nucleophilic addition reaction. Why? Because oxygen, the octet is already complete here. You can see oxygen has inherently 2 lone pairs available. So 2 plus 2, 4, again 2, 6 and 2, 8. So 8 electrons are already present in oxygen and its octet is complete, I can say. Okay, so the nucleophile will attack the positively charged carbon. Then what you will get? You will get a species like this. Correct? Then what will happen? H plus will come and attack O minus. Now students may ask, sir, from where H plus is coming? There are a lot of mediums, sir, because HCl is there, that will create lot of H plus in the medium. Okay, so there's a high probability that H plus will attack here and you will get a compound, and this compound is called hemiketol. Why it is called hemiketol? Because the ketone is a starting thing and there is only one ethoxy product added to here, and this happens by nucleophilic addition reaction is happening. Now in this question, suppose they are telling only 1 mole of ethanol is present, I can say the answer would be hemiketol. You should not think about further reaction. But in this question, they are telling excess of ethanol is present. Excess of ethanol is present means the medium will contain more amount of ethanol. So what will happen if that is the case? Please understand the medium also have lot of H plus in the medium. Why? Because of HCl that is present in the medium. So what will happen here is this ethanol will further undergo heterolytic fission and will produce ethoxide ion and H plus. And here you can see there is no more carbon with positive charge. If carbon with positive charge is present, this nucleophile can now attack it easily. But we know that the medium has lot of H plus. And please remember here oxygen has 2 lone pairs available. Now in this particular species, the attacking point is the lone pair present. Why? Because the lone pair present here create a negative charge, negative field. Automatically the H plus will go and attack the lone pair. So what will happen? You will get something like this. And you can see that one of the lone pair of oxygen is lost, and because of that the positive charge is coming here. And we know that oxygen with the positive charge is highly unstable. Why? Because oxygen is an electronegative element. It will always try to attract electrons and become 2,8. So what it will do, there are 2 pair of electrons here that will move towards this positive charge, and the bond will again undergo heterolytic fission and it will remove water. So what will happen? The carbon loses its 2 electrons or 1 electron to here. So again you are getting an intermediate carbocation, carbon with the positive charge. And this time this is stable. Why? Because positive charge, single bond, lone pair. I can easily say the lone pair will move towards here and make the system stable or stabilized by resonance, I can say. So next step, what will happen? Already we know in the medium there is a nucleophile CH3 CH2O-. So the nucleophile now finds a vacancy in the carbon. So it will easily come and attack the carbon. So you are getting 2 ethoxy group here, and such a compound is called a ketol. It's not hemiketol. Now you have, whenever the carbon have 2 ethoxy group connected, we call that, and the starting product is a ketone, we call it as ketol. If it is aldehyde, we will call that as acetol. Understood? Now what is the mechanism happened here? It's very easy to remember. Why? Because here OH, at the end of the reaction, OH is replaced by, or one of the nucleophile is replaced by another nucleophile. So I can say in the second reaction, the mechanism followed is nucleophilic substitution reaction. So I can say here the total mechanism in this reaction is nucleophilic addition followed by nucleophilic substitution reaction. So please remember, whenever only 1 mole of ethanol is present, whenever only 1 mole of ethanol is present, the reaction, the mechanism would be nucleophilic addition reaction. But whenever they say excess of alcohol is present, then the mechanism would be NAR followed by NSR. Okay, NSR means nucleophilic substitution reaction. So tell me, sir, what would be my answer? Can we go? Okay, so let's see the options. I can easily say in the same carbon 2 ethoxy groups are present, then my answer is present there. Yes, so which one is that? I can easily say option 2 is my correct answer. Correct? Because then the same carbon atom, you can see there are 2 ethoxy group is getting connected. So I can say option 2 is my correct answer. I hope you understood, and this is very, very important question. Okay. Yeah. So let's go to the last question for the day. Which of the following reagents would distinguish between cis-cyclopentane 1,2-diol from its trans isomer? Okay, which of the following reagents? There are 4 reagents given here, and which of that reagents can be used to distinguish between a cis-cyclopentane 1,2-diol from its trans 1,2-diol, trans-cyclopentane 1,2-diol. Let's see how to do this question. Listen, so this is my, all of you please focus here. Yeah, this is my cis-cyclopentane 1,2-diol. So this is a cyclopentane, and this is first position, this is second position. And cis means both OH groups are on the same side. Okay. Now I need to distinguish this between a trans compound. Okay, so I should understand that this particular reactant will react with some of this reagent, and the trans will not react. That is the way we can distinguish. Now let's take the first one, acetone. Okay, so we are taking acetone here. Acetone, we know similarly it will undergo first one the polarization, oxygen being more electronegative, pi bond will shift like this. Now think here the alcohol is present again. We will break which bond? OH bond. Why? Because here the attack should come from a nucleophile and you need to generate a nucleophile from this particular cis cyclopentane 1,2 diol. So H plus will be moved out and this nucleophile will come and attack this particular compound. Okay. Now you can see this is moving to this particular positively charged carbon to attack. So on attacking, what you are getting, this pair of electrons, will move towards the vacant orbitals of carbon and a bond will be formed between these two. You can see here. And in the next step, what will happen? O minus is present. That will be attacked by H plus. So this is the first product I am getting after the first nucleophilic addition reaction. I hope you could see. Okay. This is the first nucleophilic addition product. Now what is happening? Again, please remember in the medium, HCl would be present. Whenever alcohols react with aldehyde, in the presence of HCl, it would happen. So lot of H plus is present in the medium. Okay. This H plus will attack the OH because of the two lone pairs present in the oxygen atom. And again the same thing, oxygen will get the positive charge. So what will happen, sir? I can easily say this pair of electrons will move towards the positive charge and a heterolytic fission will happen here. Same mechanism like the previous question. So carbon will have positive charge here. Now we know that oxygen is already present here with a negative charge. So what it will do, this positively charged carbon, this pair of electrons, negative charge, will move towards the positively charged carbon. So what will happen? You will get a structure like this. You can think like a bond is being created between these two. Okay. Now I am drawing that in a beautiful way. Nothing else. Okay. So these two I am drawing in a beautiful way and this bond I am putting it like this. You can forget this. So if you do like that, you will get a structure like this and this is my compound. Understood? So this is possible only if you have a cis cyclopentane 1,2 diol. But if you are taking a trans compound, this will not be possible. Understood? Because in a if you take a trans structure, this OH will not be on the upper side, it will be on the lower side and it is impossible because of the steric hindrance for this negative charge to attack on the positively charged carbon because it will be on the downside. Okay, so I can say this is a very important question. So the answer here is acetone. Okay, so the answer here is acetone, or the other way the examiner is asking the reaction between an aldehyde or a ketone with an alcohol. The only thing is the alcohol taken here is a cyclic compound, nothing else. Okay, I can also show you one more example for making your concept, that the example that is clearly given in the text. So in the textbook, they have not given a cyclic compound. Instead, they have given a diol, ethylene 1,2 diol, or your ethylene glycol. Again, the mechanism remains the same. What is the mechanism? Tell me, sir. First step, this will undergo polarization. You can see here, it is undergoing polarization. Again, heterolytic bond fission will happen. It will create a nucleophile. Again, the nucleophile will first come and attack the positively charged carbon. And you will get a structure like this. Then what will happen? H plus present in the medium will attack the O minus. You will get something like this. Okay, either the HCl present in the medium will create lot of H plus, or this particular thing can liberate H plus in the medium through another heterolytic fission. Why? Because this is also OH. Alcohols are acidic in nature. So this H plus will come and attack this particular hydrogen. Okay, so that is what I am shown here. So this is not present here now. Now here only negative charge is present. Okay, you can see here. Okay, now what I can say, H plus from the medium will attack one of the lone pairs of the oxygen and positive charge comes here. Again the same thing, the lone pair will move towards the oxygen, the bond will undergo heterolytic fission. Okay, so positive charge comes here, again the same thing, O minus is present, so O minus will come and attack the positively charged carbon. So you will get again a cyclic ketone. Why cyclic ketone? Because the starting product was a ketone. Understood? The same example, instead of showing all these mechanisms, they simply given the product in your NCERT textbook. But it's very difficult to forget by heart this. Rather than you can do it, because the mechanism is again the same. Which one? NAR, nucleophilic addition reaction. Create the nucleophile, attack the positively charged carbon. That's it. Okay. Then the negatively charged part would be attacked by H plus. Then if excess of H plus is present in the medium, it will attack the oxygen to remove that as water. And this is called nucleophilic addition followed by elimination, removal of water. So we will see what is that nucleophilic addition followed by elimination in detail. Okay. So the product again here is a cyclic ketone. So I hope you have enjoyed today's session. So Neet is coming very fast to us. So all of you, please keep on writing, and please learn organic chemistry by writing. Then only you will remember this. There is a hand-brain coordination is there with organic chemistry. So please do write. Okay, and if you feel the content is worth for you, please consider subscribing our channel. Thank you.